Mm-mm. All right, so for 7.3, we are doing sums and differences of our radicals, okay? So just a few things to remember, okay? It says recall that the distributive property is used to add or subtract like terms. So that's kind of what we're dealing with today. It's also used to add or subtract like radicals. They have to be like. Okay, so those are the ones that have the same radicand and index. It's true. So only like radicals can be added. So if we look at this example, we have 5 times the square root of 2 plus the square root of 2. The part about them that is alike is it's the square root of 2. So that's like saying I have 5 square roots of 2 and I have another 1 square root of 2. So there are 6 square roots of 2. Okay, it's the same thing as when we say like 5x plus x equals 6x. That same thing, except now instead of having an x, we have a square root of something.
Because you're assuming that there's like it's technically like 1x. So
Right.
Thing if there would be like 1 times the square root.
Correct.
So there's technically 1.
Yep, there's technically a 1 there. Okay. Now, example 1 where we're simplifying. Do any of those look like they have the same thing? Not at the moment. I like that answer. Not at the moment. So we have to get them to have the same thing. So we just,
Give up.
yeah, like we just start in on it. I was like, don't give up.
No.
Don't give up. You're good. We're just going to start in on it. So like 32 is an even number. 8 is even and 18 is even. So I mean, and it's a square root. So 2, right, would be a good number. Anybody know 32? What is the power? 2 to the power of what?
4?
Not quite. Yes, it's 5. So again, if you did your, so the square root of 32, we're going to change to the square root of 2 to the power of 5. Okay, then we're going to have plus 3, 2 to the power of 3. Okay, and you should write this down. 18, 2 doesn't go into 18 perfectly, right? So maybe this is one where we need to do, if we don't know, the division by primes. Okay, so it's actually going to be the square root of 2 times 3 squared. Or you could do 2 times 3, or what did you say?
I was going to say 3 squared.
Okay, you could do 3 squared times 2. It doesn't really matter.
Just 3 squared. I took the 2 3
Oh.
there and the 2 from that and
Gotcha.
combined them.
Okay, I see.
That's what,
Okay. All right. So I'm going to change this up a little bit so we can see, because it's a square root. So we want how many groups of 2 to take them out? 2, right? Our exponent needs to be 2. So I'm going to rewrite this as 2 squared times 2 squared times 2. Right? So my 2 to the power of 5, I have 2 here, plus 2, plus 1 here. The reason I rewrite it like that is because then this one I can bring out here, because it's the square root of 2 squared is just 2. So that would leave me, I'm going to go ahead and do to 2 times the square root of the 2 that's left. All right, so let's do the next one. So now I have plus 3 times the square root of 2. How would I write, or the square root of 2 cubed? How would I rewrite 2 cubed to get a similar effect to what I did with this first one? 2 squared times 2. Excellent. Okay, again, because I have 2 squared, the square root of 2 squared is just 2. So I'm going to bring that out. So I'm going to have plus 3 times 2 times the square root of 2. The other one's really already set up. You're right. Right? So what can I bring out of this one? The 3 squared. The square root of 3 squared is 3. So it's minus 3 times the square root of 2. Perfect. Okay. So then if I look at this, 2 times 2 is, so I've got 4 times the square root of 2 plus 3 times 2 is 6 times the square root of 2, and then minus 3 times the square root of 2. So the square root of 2 is my like radical. So now I'm only worried about the numbers in front. The 4 plus 6 minus 3. 7. So my answer here is 7 times the square root of 2.
What if you can't make things with a like radical?
If you can't make things with a like radical, then they're simplified. Okay. That was simple enough, man. All right. I'm going to erase this one. Well, let me go ahead and do B, actually. Okay, I'll just do B over this way. All right, so we have a cube root. So how should we split up our x there?
Into x cubed plus or times x.
Okay, so we're going to have the x, or the cube root of x cubed times x minus the cube root, how about 8?
That's going to be 2 cubed.
Okay, that's 2 cubed. And how should I split up my x to the 4th? The same way we did the other one, x cubed times x. Good? All right, what can I pull out of my first one? Okay, so an x cubed, the cube root of x cubed is x, so times the square root of x, minus, what can I pull out of the second one? A 2 and an x, both come out, so that's going to leave me with minus 2x times the cube root of x. I didn't write that the first time, sorry about that. So again, my like term here, my like radical, is the cube root of x, because they have the same index. So what's x minus 2x? Negative x. To the cube root of x. You got it. But like I said, it had to have the same radicand and the same index. So the same number under the radical and the same number, the same index. Good. It's about to get ugly. Just a little hairy. Maybe not ugly even.
Are you able to take a second and recheck 1 and 2?
Okay. Yes. Okay, so let's look at 72, the square root of 72 plus the square root of negative 36 minus the square root of 98 minus the negative square root of 9. All right. What do we think there? Josh, I'm going to give this to you. Can you take this from me? Okay. Josh, will you go up and pause it then while we're thinking, since we're still, you're okay. No. Okay, so if we look at C then. Okay, how can we write 72? What would be a good way to rewrite 72? 2 cubed and 3 squared. Okay, so 2 cubed and 3 squared. Okay.
2 squared.
Thank you. Good catch. 2 cubed and 3 squared. There we go. All right, plus, how about negative 36? So again, since this one has a negative, if you remember, we can just pull out the negative 1, and then how will we write 36? What is it? Does it have a square root? You don't think so? Let you look?
Yes, it does.
It does? It's 6? Okay, so we could write it as 6 squared here, or you could take it out now, either one. We can get there. Okay, how about minus the square root of 98? Okay, so then if we don't know, do division by primes. Okay, so we've got 2 goes into 98. How many times? Enough times. 49. What could I divide 49 by? 7. And I get 7. Okay, so I have 7 squared times 2, and then minus the square root of 9. So again, I can take out my square, the negative 1. And you could leave it as 9 and then go back and find the square root of 9. Like you know the square root of 9. You wouldn't have to rewrite it. It's just how you want to do it. I'm just trying to show you a couple different ways.
I don't remember doing this one.
You may not have. Okay. So then let's go back to the first one. What can we take out of the square root of 2 cubed times 3 squared?
Take out a 2, 3.
I can take out a 2 and a 3. Is there anything underneath my radical then?
A 2.
There's still a 2, right? Because we took 2 of them to get the square root. Good. All right. Plus the negative, or the square root of negative 1. What's the square root of a negative 1? I. Yes. So this is going to be I, will be this one. What's the square root of 6 squared?
6.
So this is 6i. What can we take out of the square root of 7 squared times 2?
7,
7. Anything under the radical?
2.
Okay, the 2. And then on the next one we have minus. What's the square root of 9? 3. And what's the square root of negative 1? So what like terms can be combined here?
2's and I.
The 2's in the i's. Okay, so this one and this one. So this is 6, right? What's 6 minus, or 6 to the square root of 2 minus 7 to the square root of 2?
Negative 10 to the square root of 2.
Negative square root of 2. Okay. And then how about what's 6i? Positive 6i minus 3i. 3i. And that's finished. You're done. You don't have any more like terms. So you end up with a binomial. Okay. How do you feel about that? Good? You might be able to do it. Okay. Then let's stop here and have you all get started on your homework.